Greetings, I'm Alejandro Mendoza, and I'm here today to show you my master's final project for the Master of Bioinformatics and Biostatistics. It belongs to the Software and Application Development area, and the name of this project is Medical Software for DICOM Anonymization, a bibliographical review and development with WebAssembly of a graphical interface to anonymize DICOM images. Here we can see the index of this presentation. We have the project framework, theoretical framework, technical framework, state of the art, materials and methods, results, and the conclusions and future work. In the project framework, we have the context and justification for the project. Well, DICOM is a global standard for managing medical images in healthcare. So this thesis explores using WebAssembly to develop a web-based tool for anonymizing DICOM images. WebAssembly basically enables using desktop application code on the web, providing a fast and reliable solution for DICOM anonymization on any device. Since we can always take the code base existing for desktop applications and in a streamlined way turn them into web applications. The motivation for this project is that in the modern era, and more specifically in healthcare, the need for data privacy drives the development of an accessible, installation-free DICOM anonymization tool. What problem does this solve? Well, it creates a fast, reliable web-based DICOM anonymization tool using WebAssembly that is accessible from any device with a modern browser, even mobile devices. The objectives of this project are, well, the primary objective is to create a tool that can perform DICOM image anonymization using WebAssembly to seamlessly incorporate libraries originally developed for desktop applications into a web-based platform. As secondary objectives, we could include the design of a user-friendly web interface, that have features that are easy to understand and can be used by anyone. Also assess the performance of the proposed tool against existing desktop applications and create a detailed documentation about the use of the anonymization tool. We also have here the methodology and planification. To create this project, the methodology is one called UX design. It's combined the concept of UX designs with project development. So the idea is to divide the effort in 4 phases. Planification phase, when the persona profile is defined and some investigation is made to ensure that the initial idea is valid. The next process is constructing the data that will be needed. After that, the prototype phase is where the first prototype of the application is developed and is tested to verify if the initial idea is valid. After that, the final process is when the final user or a select group of users try the application and give feedback. Also, this project supports the Sustainable Development Goal number 10, that is reduce inequality within and among countries. Well, by using web-based technologies, this tool reduces the need for a physical resources and infrastructure required for medical data anonymization. This can help health professionals working with tight budgets with the process of medical data anonymization to ensure that the privacy of the patient is respected when data sets are created. The planification of this project, as we can see in the Gantt graphic, has three phases. An initial documentation phase that lasts for 4 weeks, the prototype and development phase that lasts for 5 weeks, and the final documentation that lasts for another 4 weeks. Now we have the theoretical framework. In the theoretical framework, here we have an image of how a DICOM image is made, the structure. Talking about DICOM, in 1983, a joint committee was formed by the National Electrical Manufacturers Association and the American College of Radiology, with the mission to develop a standard to connect various devices with medical equipment from different vendors. The idea was that all the existing devices could speak a common language they all can understand. The DICOM standard specifies the format for both the pixel image data and the accompanying metadata, as well as the protocols essential for managing and exchanging this data. As we can see in this image, the header has a preamble and a prefix. The preamble is 128 bytes and the prefix is 4 bytes. And it stores the information about the patients, the acquisition parameters, etc. In this slide, we have a table showing an example of how a DICOM attribute is formed. In the DICOM data dictionary, we have tags. These tags are unique identifiers formed by the group number and the element number. And they help to identify each attribute, like the acquisition date, manufacturer, institution name, and patient ID. Technical framework. Well, as the newest web standard, WebAssembly defines a compact bytecode format that allows it to be loaded and executed by any browser or compilation target available. With WebAssembly, it's possible to take a code base in a native language like C, C++, or Rust and compile it to be executed on the web. This project consists of a front-end application without any backend services. The main module of the application is a Rust library that encapsulates the create DICOM RS and can perform DICOM manipulation. This library then is compiled to WebAssembly and loaded from the front application. In this image, we have a simple representation of how this type of project can be structured. We have the entry point that will be the index.html and the code generated by WebAssembly inside the pkg folder. Okay, so to perform the anonymization, the browser is all that is needed. There, the DOM will load the files, since from inside WebAssembly we cannot access the file managing APIs, or most of the native APIs, by the way. And that file gets sent to the JavaScript engine, where we will get the byte buffer, because we cannot take the file as it is and give it to WebAssembly. We need to first get the buffer, and then that buffer will be sent to the WebAssembly virtual machine, where the library will get it and perform the operations like data extraction or data modification. And here we have the whole process that will be that is implemented on the application. So we start. We need to the user need to upload files. Here we have two ways to do this. One is when the file is a zip file, the file gets unzipped and all the valid DICOM images that are inside that zip file gets added to the queue. It is not a zip file, then it is a DICOM file, then it gets added to the queue. Each of these DICOM files, then we get the buffer, and with that buffer we perform the anonymization. And the final step is that if we have multiple images and we want to download it, to download all of them, we create a new zip file and download just that file. It's state of the art. In DICOM we have for the attributes we can have something called confidentiality profiles. These profiles have the goal to protect the information of the patient organization by specifying some rules about deleting or replacing the data. We have here in this table the action codes and the description of each of them. We have replaced by dummy data, replaced by zero or dummy data, remove, keep, clean, and some combinations. Here we have an example of how this will work. For example, we have action code set. That means that we can replace the data with zero or a dummy value. So we have the patient name that is in this tag position, and if, for instance, we have John Smith, we can leave it as null or replace it by a dummy string like in the next one that only accepts a dummy value, the person name. Okay. Well, about WebAssembly, WebAssembly is an abstraction over modern hardware that is independent of the language, hardware, and platform. One main goal of WebAssembly is to create code in the web that is safe, fast, portable, and low level. In WebAssembly, all the code is run in a sandbox environment, so that adds an extra layer of security. As we can see here on the image, we can take a lot of low-level languages like C, C++, Rust, and compile each of them with a specific compiler that is designed to target WebAssembly. After that, we can use it in any machine. Materials and methods. For the user experience approach, we have to develop the user journey, persona profile, sitemap, wireframes, and mockups. Also, to perform this development, we need the language is Rust, that is a low-level secure language. TypeScript, that is a language that adds types to JavaScript and is widely used in the web environment. We got React, a framework that allows us to create complex interfaces using components, and the runtime where the application will be executed is the user browser. In the user's browser, the WebAssembly code gets executed inside the WebAssembly virtual machine on a sandbox environment, and this adds a layer of security, since inside a sandbox, WebAssembly cannot interact directly with native APIs. Here we have a screenshot of the core functionality of the project, the Rust code that enables us to first get the information from a tag. We can provide a buffer that is a representation of the DICOM image and a vector of the tags that we need to access. And we have the remove or update tags, where we provide the buffer and the indication of which tag we want to modify or delete. To interact with this, we have a custom hook inside React called useDICOM. This hook loads the WebAssembly module and enables us to use it on the rest of the application. Finally, we have the use dictionary. This is another hook that centralizes all the logic related to the interaction with the DICOM tags. Here we have a structure that is defined to perform these interactions that includes the name, the group, the element, the display name, and the action that will be used for that particular tag. Results. One of the results from this project is the source code that is the Rust-based WebAssembly module and the React application. It can be found at that first link. And another one is the tool that can perform the DICOM anonymization of multiple files and can be accessed from the second link. Also, a list of user stories that describes the why and the what behind the development choices. Conclusions and future work. Well, the main objectives set at the start of the project have been completed. A Rust-based WebAssembly DICOM anonymization tool was developed and deployed. The tool was tested with real DICOM images in both the single file and the batch processing modes. So the first step was to compile the DICOM RS to WebAssembly. This step was the most difficult and at the same time the one that provides the most value, since it allows the project to use code originally developed to run on a desktop environment. Once this module was ready, there were some small changes from the mockups on the final interface, like adding a delete button to each image. And after all of this, we are able to perform the anonymization process directly on the user browser without any installations or API calls. That can greatly improve the user experience. Future work. To improve this work, we can add a pre-visualization tool, add more complete DICOM dictionary to ensure that all use cases are covered, and convert each of the components into a installable package, and also perform the necessary steps to make it completely comply with the DICOM standard. And that's all. Thank you very much